Hey everyone out there in Witcher Math Land. Welcome to today's video, which is all about basic fraction stuff. We're talking simplify, simplest, convert, simpler, reduce, all these kind of words which can end up being confusing. So very quickly we're going to learn what's the difference between some of these words. How can you tell? What's it look like? How do you know? Well, let's start with simplify versus simplest. Okay? We start with a nice big fraction that we can do things with, that we can manipulate. Let's take something like 16/24. Now, if I say to simplify this, which is also the same as saying reduce this, or put it in simpler form, those are all kind of the same thing. So we're going to make some connections up here. Those are kind of synonyms, really. What most students would do, and this works perfectly fine, nothing wrong with it, since they're both even numbers, we know we can split them in half, divide by 2. And we end up with 8/12. That is definitely simpler because the numbers got smaller. Yes, it is that simple of a language. The numbers got smaller. We know it's simpler. It's been reduced. Okay? But is it simplest? No, it's not simplest. Can we still simplify it? Yeah, they're still even numbers. We can still, if you follow me along this line here, we can still divide numerator and denominator by 2, which gives us 4/6. Right? That's a hard word to say. Anyway, is this one simplest? Got to ask yourself, and the answer, of course, is right. No, it's not simplest. How can you tell? How do you know it's not simplest? Well, if I can keep dividing, it's definitely not simplest. This is a very simple example, but it's going to illustrate the point, which ends up with 2/3. Now is it simplest? Is it? Yes, it's finally simplest. So how do you know? Let's change colors here. How do you know? How did we know to stop there? Why can't we just keep splitting it? Well, there are certain characteristics or traits that we're looking for to know by looking at something if it's in simplest form. If we have a numerator and a denominator, one or both of them is 1 or a prime number. And of course, a prime number, 1 is a prime number, and anything that has factors of only itself or 1. So if we notice factors such as 2 in this case and 3, they're both prime numbers, which tells me we can't keep splitting it. Why not? Why can't we just keep dividing it and get decimals and stuff like that? Well, because we want integers in the numerator and the denominator, okay? So we can tell by looking if it's in simplest form, if it's got a 1 or a prime in either the numerator or the denominator or both. Let's check that out. Let me give you a kind of a little quiz here. I'm just going to ask you, hey, 2/5, is that simplest? Well, 5 is prime and 2 is prime. We can't divide both 2 and 5 by 2, for example. So, simplest. That one is simplest. Let's do another one. What about 9/3? 9 is a prime number. 3 is a prime number. So you might think, well, yes, of course, this one is simplest based on this definition over here. But the thing is, do they have a common prime factor? And the answer is yes. We can divide top and bottom by 3. And now we have 3/1. Now it's simplest. Okay. That's going to take care of this video. We're going to do another one that we'll talk about simplify versus simplest, simpler, and we'll also talk about reducing and converting. This was horrible, and